Good morning, everybody. This is Mr. Grams. I'm putting together a little video for Mr. Gould since he's not around today for you to watch about solving kinematics problems, word problems. Step-by-step approach is the page. Page 42 and 43 is where you can follow along in your workbook in the beautiful blue CP1 physics workbook. So I'm going to make my video a little bit smaller here so I'm out of the way, but I'm still hovering as we go. The first thing you'll notice is there are a bunch of steps here, and we're going to try to go through them one by one, and then there's a group of kinematics equations. So I'm going to drop myself down here in the corner for now and get myself out of the way as I need to. So the first thing we do is we read through the problem, of course. That's always an important thing. So I'm going to start by reading the problem carefully and try to make a prediction. So if I'm looking at this, stuff, you're in a car traveling on a straight level road at 30 meters per second. So 30 meters per second is definitely a piece of information we're going to need. You see a school up ahead and apply the brakes. That means you're slowing down at a steady rate to final speed of 10 meters per second. While slowing down, the car travels a distance of 90 meters. What was the acceleration? So the things I've highlighted here are all the things that we would either need to figure out or we would need to use to solve this problem. So taking a look at this, the first thing it asks us to do is, after I've read the problem, do a prediction. It wants to know the acceleration. So the information I have about that is slowing down while traveling 30 meters per second down to 10 meters per second. And when I see that, I say, well, I've gone from 30 down to 10. That sounds like a negative acceleration. You can make more detailed predictions if you like, but that's the kind of prediction I would make. That's a negative acceleration. The next thing you want to do is draw a diagram. So draw a diagram, that's over here. And the things it should show is the origin and the x-axis. We can point the coordinate system in any way we want, but we want it to make sense. So we've got a starting point, and we're going this way. So I'm going to call this 0 and this my positive x direction. My car then would start here. I'm not a very good artist, but there you go. There's a little car, I think. And it's traveling this way. The velocity at the beginning, and initially the little I is going that way. So that's my picture. At some point it goes and then it stops. You could say a few other things you can add, but the basic stuff is important, is that there be a 0 and a positive direction. The next thing we want to know is write down everything we know. Does it stop, that kind of thing. So what we know is the wanted thing. Well, if we go back up to our problem, and I feel like I'm getting a little bit of out of focus here, but the acceleration is the thing we're trying to find. So I'm looking for the acceleration, which is little a. What do I know? Well, I know that my initial velocity is 30 meters per second, right? Because that was given to me. I know that my final velocity is 10 meters per second. So it doesn't fully stop. I know that it travels a distance of 90 meters. And so this is one that we might want to put out and say two things. Well, I would say my initial position in the x is 0 meters, because that's where I put my car. And my final position is equal to 90 meters. 90.0. I should have put the point zeros there, but you get the idea. So these are the things I know, right? Final speed, initial speed, distance of 90 meters, and an acceleration. It's good to notice that this distance of 90 meters means that from our starting point, we went 90 meters. So 90 meters, this is where we kind of are at our ending point. I'm adding to my diagram, making a little dotted line car. Be like, there's where it shows up after 90 meters. And if we look at our variables, going back over to this side, what variables are known? We said we knew initial and final position, initial and final velocity, and we're looking for acceleration. But you'll notice that we don't have time. And so time is the variable I'm going to write down as my not given. And that's going to allow me to pick an equation. So if you look at these equations over here, we've got equation 1, 2, 3, and 4. And the way we're going to pick something is by picking our not given variable. And our not given was time, which means equation 4 is the equation we're going to want to use. And so that's what we write down for step 4. We write down our equation. V final squared equals V initial squared plus 2 times the acceleration times the quantity x final minus x initial, right? So that's our equation. The next step says, select the right equation. We already did that. The next one is simplify the equation, eliminating anything that's 0 and then isolate symbolically. So those may not be things that make a ton of sense to you in first reading, but the first thing we want to do is look and see what was 0. Well, 0 was the initial position. So usually what I do is put a little line through it and say, that one's 0. Then the rest is stuff that we're going to either find or know, so I'm going to leave that alone. I'm going to rewrite this as V final squared equals V initial squared plus 2a times x final, right, because that 0 went away. The thing I'm looking for, I'm trying to isolate, was the acceleration, right? That's my wanted variable. So I'm trying to get that alone. So I'm going to subtract V initial squared from both sides. And that's going to give me V final squared minus V initial squared equals 2a x final. I'm going to move over to have another line of algebra. I'll just rewrite that. V final squared minus V initial squared equals 2a x final. I'm going to divide both sides by 2x final because that's going to get rid of these two terms. And I'm going to leave a on one side, and then that'll leave this here. So I've got V final squared minus V initial squared over 2x final equals the acceleration. And I could, if I wanted to, put those on opposite sides and say a equals V final squared minus V initial squared over 2x final, because that's kind of more standard form. But either one of those is okay. Now I'm going to move myself out of the way a little bit up here so that we can keep going. The next step is the calculation. So if we go back over to step 6, it says plug in your data, including units at signs, then do your actual calculation. So this is the part where I take that a from up above and I say a equals, what was V final squared? So V final is 10 meters per second. So 10 meters per second. And I square it. Minus V initial squared, so 30 meters per second squared. All of that is divided by 2 times x final, which is 90 meters. And from there, you could carry this out by hand. I usually am one to grab a calculator and then kind of do my calculations. I've got 10 squared minus 30 squared. Then I divide that by 2 and then divide it by 90. And I'm left with negative 4 points. And if I look at my number of significant figures in my problem, I've got 3 in all of them. So I'm going to go 4.44 meters per second squared because that's the units for acceleration. And so then I want to check, does this make sense in number 7? It says check your answer for correct signs, units, and significant figures. Does it make physical sense? So let's look. Well, we said we would get negative acceleration, and indeed, we have negative acceleration. That makes sense. The units are meters per second squared, which are the correct units for acceleration. And I mean, the number, I don't know that we have any particular way of knowing that the number is correct, but we do have a number. It's not incredibly huge or incredibly small, which is usually a good check. And so I would say units and sign are correct for negative acceleration. Yay. So that's a check. It works out. So that's an example of how to use these kinematics equations. Now, we just used one of them in this example, and depending on which problem you're solving, you might pick a different one. But the big idea, I think, is once you've gotten your picture and kind of found all your knowns and unknowns, The step 4, selecting the equation, comes from seeing what variables you are looking for and what variables you have that are known, and then picking an equation that doesn't ask you for something that you're not given. And that's kind of the key to solving those problems. So I hope that helps you get going. Have a good one. Enjoy doing some physics.